Hello, I'm going to review Chapter 16, Sections 16.3 and 4. So what we're going to do first is determine the inverse of this function. So there are a few steps that we took. The first thing we're going to do is replace the f of x here with the letter y. So I'm going to rewrite the equation as y equals 2x minus 1, which is the equation of a line in mx plus b form. So once you flip-flop the x and y, or I'm sorry, that's what we're about to do next, is once you rewrite this as y equals, we're going to flip-flop the x and y. Again, because when you're taking an inverse of something, you are reflecting it over the line y equals x and x equals y, so we flip-flop them. And now all you're going to do is solve for y. So what I'm going to do is add 1 to both sides, and I get x plus 1 equals 2y. And then what you would do is divide both sides by 2. Remember to divide everything by 2 on that left side as well. So you end up with y equals x plus 1 over 2. If you want to simplify this, you can put it as x over 2 plus 1 over 2, or just leave it. I'm going to rewrite it then at the very end as f inverse of x. That's the last thing you have to do. F inverse of x equals x plus 1 over 2. Again, that's also an equation of a line. If I do break this apart into x over 2 plus 1/2, think about what this line would look like. It would have a y-intercept of 1/2, and your slope would be up 1 over 2, up 1 over 2. With the other line, it starts at negative 1, so your y-intercept would be down 1, but your slope then would be up 1 over 2. Up 2 over 1. So your slope of your inverse function is actually the reciprocal of your slope of your regular function. It says tell if the inverse is a function in y. So that's where I'm going to type this part in. Open a text box. What the crap just happened? Okay. Okay, so I'm going to say, let's see, determine, blah, blah. So we found the inverse. Okay, so tell if the inverse is also a function. So the inverse equation is also a function because it is a line represented in slope-intercept form, and the line is not vertical. Okay, so the only way that you would have a line that would not be a function is if it were a vertical line, because then it would fail that vertical line test, meaning it would have multiple outputs. One input would have multiple outputs. So again, if you're taking the inverse of any line, it's always going to be a one-to-one function, because lines are always functions unless they are vertical lines. Next problem. So we're going to determine the inverse of this. So same process, except notice we have a squared here, which means it's quadratic, so it's going to be a parabola. So try to get this one yourself. Pause the video and try to get it. I'm going to replace f of x with y, and then bring down everything else. Next step, again, since an inverse is a reflection over the line y equals x, you're going to flip-flop your variables. And then what we're trying to do is solve for y. So I'm going to subtract 20 on both sides. Make the sound. So x minus 20 equals negative 3y squared. Blah, blah, blah. Okay, now we're going to divide both sides by negative 3. I want to get the y squared by itself. So at the very bottom here, I'm going to bring the y squared over here, and I'm going to rewrite this expression as, the equation as x minus 20 over negative 3. All the way up here then, at the very end of this problem, you're going to end up with y equals plus minus the square root of x minus 20 over negative 3. And then at the very end, we're going to replace the y equals with f inverse of x, and then just bring down the rest. Okay, so that's the inverse equation. So since the inverse function is under the square root, again, picture what this graph would look like. First of all, negative 3x squared plus 20 is going to be some parabola that's going to look like this. And then when we flip-flop it, 0, 6, 6, 0, it's going to be something that's going to turn to the left, where again, you're getting the sideways function for an inverse. Anytime you draw a vertical line through that function, it's going to fail the vertical line test. So I'm going to type the response again. Blah, blah, blah. Okay. flipping out. Alright, so I'm going to say the inverse equation is not a function because it fails the vertical line test, and let's kind of extend onto that. Even though it's precision, it's not a justification question, I still want to give a little bit more and say every time a parabola is reflected, I'm going to have to slide this response up, this is going to be crazy. Every time a parabola is reflected over the line y equals x, the graph becomes a square root function, and inputs have multiple, I'm going to have to slide this up, multiple outputs. So again, anytime you have this quadratic type function, you can see the algebra behind it, but it's kind of important to have a little idea in your head of what the sketch looks like. So we have a square root function that's going to have the positive side of it and the negative side of it. But again, every time you take a square root of one of those numbers, it's going to do the inverse of squaring something, and you end up with two answers. So one input has two outputs for all of those quadratic functions. Okay. Kind of a crappy explanation, but again, it was a precision type question. I'm really just looking for like a little bit as to why that why that equation was not a function. In this one, this is going to be a justification. So I'm going to really be typing this response in, and I'm going to try to give a really full response, kind of just like what I just said in the last one, except I'll use complete sentences here and say the domain of the function, or the solid function, is all real numbers. And again, that's because everywhere on the left side, if you keep going negative, negative, negative on your x values, you're still going to end up with a y value. And same thing for your positive values. So every value of x works. So the domain of the solid function is all real numbers, and the range is y is greater than or equal to 1. So notice the lowest point here on my curve is at positive 1. So all of your y values are going to be greater than or equal to that, which I could have probably just done this. Oh wait, no, I was going to use the greater than or equal to sign, but I can't find that. So I'm typing it, whatever. Okay, so that's your domain and range of the solid function. So the domain of the inverse function is x is greater than or equal to 1. And again, that's because if you look at these values, so this curve is sideways, all of your x values start here at positive 1, and they're all greater than or equal to that. We're not focused on the y values, just thinking about the x values. So again, you're taking the range from your solid function, and it becomes the domain of the inverse function. But you have to remember to switch your x and y. So now you wouldn't tell me that the domain is going to be y is greater than or equal to 1, because domain is dealing with x values. So the domain is x is greater than or equal to 1, and the range is all real numbers. And again, it's all real numbers for a couple of reasons. The range from the solid function, the domain from the solid function right here is all real numbers, and that becomes the range of the inverse function. Another way to think about it is this curve is going to, the top side of it's going to keep going positive, 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 and the bottom end is going to keep going negative, negative, negative. So again, every y value gets hit. Now it says use math vocabulary to justify these answers. Let me think. Best way that I would want you to explain this. The domain of the inverse function is greater than, or is x is greater than or equal to 1, because if you substitute a value less than 1 into your inverse function, you will get an imaginary answer. Okay, so think about what that means. And again, we don't have a function present to show us this, but if you think about it, if we were to pick a value of like 0, whatever the function is, since there's no point here, it means when you take the square root of that number, you'd be taking a square root of a negative value. So again, you would not have a point here that would be real. It would be an imaginary part, and that really explains why the domain of that inverse function is greater than or equal to 1, because any value that's less than it will have an imaginary point. Okay, next one. So this one's a problem solving. We're going to determine if these functions are inverses of each other. So again, what we're going to do is a composition of functions where you're going to take the g of x function and substitute it into the f of x function. And what we really want, this is what our goal is to get f of g of x to equal x. Again, the reason is whenever you do the f of x function, so in this case it's going to multiply it by 10 and subtract 10. When you do the g of x function, you really want it to do the opposite, which we use the word inverse. So if a function is going to add 3, you would want your inverse to subtract 3, and you would be left with whatever this variable is. So we're going to take this chunk right here, this is what g of x is, and I'm going to substitute this all the way over here into my f of x function. So f of 1/2 x minus 1 over 10, again, I'm just basically substituting my g of x function right here, and I'm going to rewrite over here. I have 10 times 1 over 10x minus 1 over 10, and then it says minus 10. It's a lot of 10s. Okay, so watch what I do here. It's kind of a little trick. I'm going to rewrite this as 10 over. Now, I'm going to take, since we have the same denominator here, I'm going to take the x minus 1 here, the 1x minus 1. I'm going to put that on the numerator and put a 10 on the denominator and bring over the minus 10. Okay, so I basically just cleaned up this these two fractions and simplified it into 1, and what that allows me to do is cancel out these 10s. Okay, so we're left with x minus 1 right here, and then you have a minus 10, and this is going to come out to x minus 11. So again, f of g of x is x minus 11. So what that means is that g of x is not the inverse to the f of x function. Again, the only way that it would have been the function is if at the very end you would have done this whole process and you would just get the letter x. It's the last one then. Okay, so I kind of broke this into parts. What we'll do first is complete the table of values. I brought the graph onto the next slide, and then we'll answer the questions that go with it. So first thing is to realize, again, in this function it is a quadratic. We have the squared on the outside, so it's going to be a parabola. So I'll kind of go through what you guys can do in a graphing calculator to get this. But again, this x plus 3, it's really important to remember that that's going to take your vertex point of your parabola and it's going to shift it to the left, or it's going to translate it, I should say. It's going to translate the graph to the left 3 units. What that tells us we should do is put -3 in the middle, and then you can build some numbers on the other sides of this just using integers. And remember, whatever x's you put here will eventually just bring them over here for the inverse function and flip-flop the x and the y values. What you guys can do is go to the graphing calculator. If you don't want to substitute every one of these values in, what I can do is go to y equals, and I'm going to type in this function just as I see it. -x plus 3 squared. Okay, and once you have that in, I'm going to hit second and then graph. And it's going to give me a table of values. So I'm looking basically for the values that I have on my current table, and then I can just fill in. If these are my x's, I'm going to take a look at the associated y's. Looks like I have -4, -1, 0, -1, and -4. And again, when you do your inverse function, all you're going to do is flip-flop your x and your y values. Again, anytime you have an inverse function, it is a reflection over the line y equals x, so your x's become your y's and vice versa. Blah, 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 blah. Okay, so I have a parabola for my original graph, and it would be a square root function for your other graph. So I completed the table of values, we're done with that. Sketch a graph, use a solid line for the function, and then a dotted line for the inverse. So I've already done this. So take a sec to kind of consume this information. You do not have to draw the green line. I only showed that so I can again emphasize that the function in blue, the solid line regular function, is going to be reflected over that green line. And if you were to like maybe put the blue line on a piece of paper and then fold it over, you would end up, if you fold it over that green line, you end up with the dotted line function. So again, take a sec, copy in, make sure you have the table of values down, copy in the graph, and then we'll explain if this is a one-to-one function. And again, since this is a problem-solving problem, I'm looking for a full answer, but I'm not looking for, like I would be on a justification question where I want you to just pile on the vocabulary. Albeit, kind of easy when I grade these is to say, if you just show me that this inverse function is going to fail the vertical line test. So what I'm going to do is take my little line tool. I'm going to draw a vertical line through anything here. So I drew a vertical line through, and since it crosses this sideways parabola looking thing twice, it fails the vertical line test. So if your function or the inverse function, or I should say if your equation or your inverse equation is not a function, if either one of them is not, it means that your function f of x is not a one-to-one function. So I'm going to say f of x is not one-to-one because the inverse function fails the vertical line test. And I'm just going to say VLT again. So it fails the vertical line test. Now, if this were a justification question, I'd really want you to go in depth on telling me why does this sideways parabola fail the vertical line test. Since it's problem solving, if you were just to draw in a vertical line like I have, and I'm really kind of trying to bold in these 2 points where it crosses, you are showing me graphically that it fails the vertical line test. Which you could also do if you really want to like make this point across and just show more work, is you can go over to this table of the inverse function, and it's really obvious that you can see on a table that your x values, so like -4 goes to -5, and then it also goes to -1. So this one input has multiple outputs. The same thing happens on your table at -1. It has 2 outputs, and that can't happen in order for it to be a function. So again, if your regular equation or its inverse is not a function, then that means that your regular function f of x was not one-to-one.